Thank you. So today we're going to look at 6E, angles in all different quadrants. So prior to today, we've only looked at angle, we pretty much only look at angle in the first quadrant. Remember in the past, doesn't matter in year 5.3 and last week, we only look at 30, 45, 60, 90 pretty much, right? So today we're going to expand into second, third, fourth quadrant. So let's draw a number plane. Now, obviously we're still going to have a look at the angle in the first quadrant first. So just now we said when we measure a positive angle, we start from the positive x-axis and go anti-clockwise. Yeah, when we do that, we reach an angle like this. And we call that theta. Yeah. Then suddenly we have angle theta. We'll have a look at angle in the first quadrant. We call that y, x, r, which we had a look just now. Then we'll have a look in all the angles, all the ratios in the first quadrant. Let's have a look at sine first. Sine theta is equal to y over r. Now, when we discuss this topic, not only do we interested in the ratio, we're interested in whether it's positive or negative. So y is positive, r is positive. Positive divided by positive, it's gonna be positive. Yes? Good? Okay. So we say that sine in the first quadrant is positive. Move on. Cos theta. Cos theta is equal to what over what?
X over R.
X over R. Fantastic. X over R. So once again, that's positive. Hypotenuse obviously is positive. So once again, positive divided by positive, we get a positive ratio. Tan theta. Tan theta is y over x, right? Opposite over adjacent. Y over x. Now once again, positive divided by positive, we get positive. All good? Now, we're interested in sine, cos, tan, all those basic trig ratios. Then we say all ratios in the first quadrant are positive. We're going to use the capital letter A to stand for all. Means all are positive. Okay, that's everything we need to know for the first quadrant. Then we'll move on to the second quadrant. We'll keep rotating, right? In the first quadrant, starting from the positive x-axis, we keep rotating anti-clockwise. Then we'll have an angle like that. So we call this angle theta as well. Yeah. Now obviously, this one here is going to be 180 minus theta. You agree?
Yeah.
Okay. Let's have a look at. We use exactly the same idea to generate the ratio in terms of sine, cos, tan. Okay. So that's x, that's y, that's r. So sine theta in the second quadrant is y over r. Okay? Y over r. Let's have a look. Y is positive. R, hypotenuse, is always positive. So the ratio is positive. Cos theta is x over r. X is negative, right? It's on the negative part of the x-axis. That's why it's negative over positive. So the cos theta now is a bit different now. It's negative. Yeah? Finally, tan theta. Tan theta is opposite over adjacent. Opposite over adjacent. Positive over negative is negative. So the conclusion is we see that in the second quadrant, only sine is positive. Very good. The negative is going to be S. Good. Keep rotating. Now we're arriving in the third quadrant now. right? In the third quadrant now. So we call this angle theta here. Now have a look at here, in the first quadrant we call theta, obviously that's our basic starting angle. In the second angle we call 180 minus theta. Have a guess, what do you predict angle in the third quadrant is going to be called?
180 plus theta.
Perfect, very good. That's 180 already, right? And just plus theta. No, these are all theta, theta, theta. By the way, that's called the reference angle. The angle between the actual ray to the x-axis. Okay, so now we call that. And I'm just going to extend a little bit. So we call this one angle here 180 plus theta. No, sorry, it's a bit small, but you get the idea. All right, so that's x, that's y, that's r. I'm moving to the third quadrant now, right? So let's have a look. Sine theta is equal to y over r. Y is done this part of which is negative. Negative over positive is negative. Follow?
Yeah.
Cos theta. Cos theta is x over r, right?
Yeah. Negative.
Make sure your mind is me. Check. Okay, tan theta is here. Y over x, right? Y is negative, x is negative. Negative, negative is positive. Perfect. So we see that in the third quadrant, only tan is positive. We use letter T. Cool? ASTC, fantastic. That's where it came from. Okay, we haven't fully finished yet. Now we're going to see where the C come from. Okay, we'll keep rotating, right? Rotating. Keep rotating to the fourth quadrant now. So that angle is theta.
360 minus theta.
Perfect. That's what I was going to ask. 360 minus theta stands for the angle in the fourth quadrant. So if you go like this, stands for 360 minus theta. This topic I really like it. Okay, so here we'll get 360 minus theta. Then we'll do our x, y, r piece again. Right, so here we go. Sine theta is opposite over hypotenuse, y over r.
Negative.
Y over r is
Negative.
negative. Cos theta is
Positive.
x over r. Positive. Fantastic. Tan theta is
Y over x. Negative.
y over x. Well done. Negative. Conclusion? What's the
C.
conclusion? C. In this quadrant, only cosine is positive. Well done, guys. That's how we reach our conclusion of ASTC. In many textbooks, in our textbook, you will see that's where ASTC as an abbreviation for people to remember what's going on. Some people say all station to central. That's how you remember it. Some people say all students take calculus. Okay, move on. All good? Okay, by the way, after today, I strongly suggest that you do remember this picture. Right? That's abbreviation how you remember it. In the past, like year 9, year 10, last week, we're only focusing on this quadrant, remember? 30, 45, 60, 90 at the maximum. Now we move to all other angles. Yeah. Later on, we're even going to move beyond 360. You just go one more circle. Just keep rotating. Okay, let's have a look at some of the examples, right? Okay, so I'm going to do a few, I'll ask you guys to do a few, right? So let's have a look at sine 210 degrees. The idea is without using the calculator, find the exact value. Find the exact value. Give it a go. Sorry, first one is the example, I will do it. Sine 210. Whenever you look at this sort of thing, you always have a look at where is my angle located first. Alright? In other words, before I worry about sine cos 10, where's the angle?
It's just minus a half.
The third quadrant.
Third quadrant, very good.
It's just sine
So this
30.
one is 180 plus 30. Right? So 180 plus 30 is in the third quadrant. But what I'm really interested in is I'm really interested in the reference angle, which is 30 degrees here. And sine 30, from memory, straight away is half. But the angle is located in the third quadrant. That's why it's negative half. Done. Easy?
Yeah. Cool.
Cool. Okay. How about another examples are very repetitive. So I'm going to do something a little bit different. How about, can you guys try? 10, 135. Give it a go. So remember what I said? Starting from the angle first. In other words, where is 135 located, right? Where's 135 located?
Second.
Second quadrant, very good. So how can I get 135?
90.
90 plus?
45.
Well done. Yeah, that's 135. So what's the reference angle? Reference angle is 45 degrees. ASTC. 1045 is?
Negative. Not a clear.
1045 is?
Half. 1.
1. And so 135 is?
Negative.
Minus 1, very good. Okay, let's have a look. I'm going to do another one. Let's do a negative angle, right? Sine. After this one, I'll stop the video. Okay, remember what we said just now? If it's negative angle, which direction am I rotating?
Would the ASTC like go in the opposite way?
No, ASTC stands or stay the same. Well, or stay the same. But negative angle, right? So instead of going anti-clockwise, I go clockwise. So that's 0, minus 90, minus 80.
30.
I didn't draw very well, but you get the idea. So that'll be
30.
30.
How do we know it's 30? Oh, I can't do that.
Yep. 0, minus 90, minus 80, minus 80. And you do another 30 to get into minus 210.
Yeah.
Right? So that's basically how you rotate. Then again. So, what is it?
Negative half.
Is it half?
What is it?
Is it just half? Or
Just half. Yep. Because sine in that
Oh.
quadrant is positive.
Yeah.
Very good. I'll give you some last example. Actually, I'm going to do the final one. Cos 570. A little bit different now. Add a little bit extra thing, but the idea is exactly the same. Alright, let's give it a go.
30 degrees in the third quadrant.
So, good, let's have a look. That's obviously larger than 360, right? So without thinking, I'll do one full cycle first. That already gave me 360, right? So 570 minus 360 is what?
210.
210, very good cycle. Which means I'm going to do cos 210. I'm going to start rotating again. Give it a go in your head or in your book. Which quadrant is my final angle? Third quadrant. And cos in the third quadrant is? Negative. So what's my final answer?
It's like root 3.
This is what I mean by last week. We need to be very, very quick and proficient in 30, 45, 60.
Root 3 over negative root 3 over 2.
Perfect. Even though we're dealing with large angle, ultimately when you break down, you are dealing with 30, 45, 60. Yep.
Yeah.